Pre-calculus students and general seekers of truth, let us continue here with some videos on how do we solve logarithmic equations. So an equation that has a logarithm statement in it has to be treated a little bit differently than the other ones. So I'm going to remind you maybe on the side here of a general strategy that I think will be helpful to all of you. And this general strategy is we want to condense logs, okay, on both sides of the equation. So this is one strategy. It's not the only one. We want to condense logs on both sides of each equation that we work with. Okay. So, and I'll show you how that works in this case. So I'm going to condense the logarithm on the right side. And so this will give me log of 3 squared. And this again is the power rule of logarithms. On the left side, I have a subtraction of logs, so I'm going to use the quotient rule. So this is going to be log of x minus 2 over x plus 5. Okay. Now, once I was able to condense the logarithm on both sides to a single logarithm, then what this tells us is the inside of the logarithms have to be equal, right? So all this stuff in here has to be equal to all of this stuff in here. Otherwise, the equation would not be true. Okay. Let me get rid of this highlighting here. I just wanted to do that to make a point. Okay, so we can now take away the logarithms and we can say that x minus 2 over x plus 5 must be equal to 3 squared, which is 9. And then from here, it's a relatively simple process. So we multiply both sides by x plus 5. So I get x minus 2 is equal to 9x plus 45. I add 2 to both sides and then subtract 9x from both sides, and I get negative 8x is equal to 47. And so that means x here will be equal to negative 47 over 8. Okay. And that is normally our answer, except in this case, we have to be very careful. We have to check our answers. Okay? We check this by plugging it back into the original equation. And we don't have to do too much arithmetic here. You can see that here, if I take negative 47/8 and I plug it into here, I get the logarithm of a negative number, which we know that we cannot do. So this answer doesn't work. So this answer is actually extraneous. Okay, so this is kind of tricky, and in our work here, there's actually no solution, no answer to this problem. Right, so I sort of led you down a path here, and ultimately it's a dead end. But hopefully this helps you to remember the basic idea that you have to check your solutions. Well, let's look at another example here where we are going to use properties of logs. And same as before, we are going to condense our logarithms. Okay, so when I condense the logarithm on the right-hand side, I get common log of 2 to the third, and that's again the power rule. On the left side, I get log of x minus 3 times x plus 4. Now, because once again we have a singular log statement on the left and on the right, I know then that what's inside of the logarithm statement must be equal to each other. So we can say that x minus 3 times x plus 4 must be equal to 2 to the third, which is 8. And now you have really a quadratic question. So we multiply everything out, distribute x squared plus x minus 12 is equal to 8. Subtract 8 from both sides. X squared plus 4 minus 20 equals 0. This quadratic can be factored, and factored quite nicely. So we will get what do we have here? Well, you know what? I think I made a small mistake. It shouldn't be 4x. It should just be x, because you have negative 3x plus 4x. I went a little bit too quickly there. Sorry about that. Let's correct it. So this is x squared plus x minus 12, x squared plus x minus 20. Now we can factor this quite simply. So this will give us x, when we factor this, will be x plus 5 times x minus 4 equals 0. So solving both those equations, I get x equals negative 5 and x equals 4. Okay. Now, once again, just like we did in the last problem, we have to make sure that our answers are good, so we have to check. Okay. So let's see, if I take negative 5 and I substitute it into the original equation, negative 5 minus 3 is negative 8, log of negative 8 is not real, there's no real answer to that, so this is an extraneous solution. If I put 4 into here, then that will work. So log of 1 plus log of 8, that's equal to log of 8. So in this case, I have one extraneous solution, and the other here is the correct answer, x equals 4. So there you have it, another good example of solving problems with logarithms with the technique of combining the logs and condensing. Alright, so I've got one more example here of solving equations, and we're going to apply a slightly different technique in this case. So first we are going to condense our logs. So I have log base 3 of, and this is the quotient rule in action, 13x plus 4 divided by x minus 2, and this is equal to 2. Now you might be thinking, well, normally we condense logs on both sides and set the inside of them equal to each other, except in this case it's a little bit different because we don't have a log on the right side. So we're going to apply another technique here, and this one I like to call it just converting forms. Oh, excuse me, I don't know what's going on there. Let's see. So this one I call it converting forms. Okay. So this is a second technique. We're going to say convert to exponential forms. And so we effectively get rid of this logarithm. So when we go to exponential form, this is 3 to the second power, this is the base, this is the exponent, is equal to 13x plus 4 divided by x minus 2. So from here on out, it's a relatively straightforward equation, I think. I multiply both sides by x minus 2, so this is 9 times x minus 2. That's 9x minus 18. And this is equal to 13x plus 4. Then I add 18 to both sides, and I get 22 on this side, subtract 13x from both sides, and I get negative 4x. So that means x must be equal to negative 22 over 4, or 11 over 2. And once again, we have to check our extraneous answers. In this case, negative 11 over 2 is an extraneous answer, because substituting in here, we would end up with a non-real answer. So this is extraneous, and there are no real solutions to this problem. But I hope you get the process here, even if our final answer is extraneous. As always, ask for help if you need it. Thank you for watching, and have a wonderful